How's it going, guys? My name's Galen, and I'm going to be teaching you about periodic trends. Woohoo! Okay, so the thing is that there's many different types of periodic trends and specific information about each of these things. So I'm really just going to be teaching you the basics and not going like too far in depth with them because they'll be their own videos. So. Alright, so let's get started, and we'll see on group 1 we have the alkali metals and hydrogen, which is the first element. These are just sort of the basic categories that it's divided into. And then we have the alkaline earth metals in the second group. Then that period, or another period I should say, the big category of transition metals falls from group 3 to 12 in that middle section there. I'm not worrying too much about the difference between the basic metals and semi-metals. Those are all sort of their own thing right there. They're transitional, just at the end of the transitional metals. Halogens come next, over in group 17. And then we have the noble gases in group 18. And then also the category of the lanthanide series falls from elements 57 to 71. And the actinide series is elements 89 to 103, and those are the two sections that are underneath the periodic table that are usually just put into their own little spot. This is kind of the basics of how the periodic table is divided. Also, you can see on the normal periodic table a little bit into electron configuration. Now, me and Matt did a different video on that, so I'm not going to go too deep into that, but as you can see, like the first s orbital, 1s2, the 2 at the end would be the hydrogen element and helium, and then 2s2, lithium, beryllium, and it's a group of 2, and then it goes to 2p6, and the next section is a row of 6, and it would be boron, carbon, nitrogen, oxygen, fluorine, and neon. So you can see how it works out as they're all divided into the numbers that work for the electron configuration. Alright, next we have electronegativity, and as you move to the right or up on the periodic table, the elements will become increasingly electronegative. Now you'll also notice that omitted from this section are most of the noble gases and the lanthanide and actinide series. Those are just sort of not a part of this, but as you do move right and up, it increases. It is a little weird in some parts, but it's just sort of because of the fact that elements have a sort of desire to be filled, they have their electrons filled in some way, and that deals a lot with electron configuration, and you can check that out more in the other video and learn a little bit more specifically about that. But this is just sort of showing the trend of how moving up or right will increase the electronegativity to fluorine, which is the greatest, and down to francium, which is the least. Alright, next we have the atomic radius. And the atomic radius is sort of just the size of the atom itself, and this is the opposite of electronegativity. And as you move left and down on the periodic table, the elements get increasingly bigger, and this makes francium the biggest, and like helium very small, fluorine very small, neon very small. So it just sort of shows the growth of the element and the atom of the element, and it all sort of works out in the way that it's just a slope downward towards francium in an increasing size. Next up we have ionization energy, and you'll notice that this is going in the opposite direction as atomic radius. And ionization energy is how much energy you need to remove the first electron and then the subsequent electrons off of the exterior of the atom. And you can see that it takes less energy to remove the first valence electron from francium than it does, say, fluorine. This is partially because francium is a much larger atom, so it's not as tightly packed, and the center of it does not have as much of a hold on the exterior electrons as one of the smaller atoms does. So if you think about it as francium's sort of bigger and not as tightly packed, so you can sort of pull the electrons off a little bit easier than that. But then you look over at things such as like neon and fluorine, where they're so small that any electrons that are on them are very close to the core, and that makes it much harder to remove them from the atom. So yeah, that's just sort of a run through of the basics of periodic trends. Now there is, like I said, a lot of different specific information that can be taught on each of the categories that I gave you a brief overview of. So that's just sort of a shortened version of different periodic trends. So now we'll get on to some practice problems. I'll just read them off to you quick. Which element is more electronegative, fluorine or oxygen? Which element has the largest atomic radius, francium, cesium, or nitrogen? Which element on the periodic table has the lowest ionization energy? That one's just up to you. Which of these is a noble gas? Helium, argon, chlorine, and zinc. And what special series of elements are the elements from element 57 to 71? Alright, so just pause the video and try and answer these questions, and the answers will be up in a few seconds. And the answers. Alright, let's see if you got them right. Which element is more electronegative, fluorine or oxygen? Fluorine would be the correct answer because it is the most electronegative element, and it is in the top right of the periodic table, which is where the electronegativity trend tends to point towards up and right. So when you go all the way into the top right corner, you'll find the most electronegative element. Next is francium, which is the largest atomic, or which has, I should say, the largest atomic radius, and it is basically the same circumstance as fluorine was in the previous question. It follows the trend of going left and down, and in the bottom left corner you find francium, and that makes it the biggest atom and the biggest element because it is in the bottom left corner of the periodic table. Alright, so which element on the periodic table has the lowest ionization energy? Now, previously I had helium there because I switched it up in my head and I accidentally wrote lowest when I meant to write highest. But because I wrote lowest, I'll simply just give you the answer for lowest, and that's actually francium. My bad, as you can see. And that is because francium is the biggest molecule, and as I said before, it doesn't have as much of a hold on its valence electrons as other smaller atoms that have their electrons closer to the core. So in this case, it takes the least amount of energy to remove the first and then subsequent electrons as it does, or than it does the smaller atoms. Alright, so which of these is a noble gas? Helium, argon, chlorine, and zinc. Bear with me here, I apologize, I'm sick, and I accidentally wrote two noble gases. I was thinking helium, I'm still messed up, I was thinking oxygen when I wrote helium. So if you answered either of those, you would be correct. I was going for argon, but you know, you would be right either way. So that's mainly, though, regardless, just a memorization of the periodic table and like how the 18th group would be the noble gases. Finally, we have what special series of elements are elements 57 to 71, and that would be the lanthanide series. That is another memorization thing. That's sort of just recognizing that this little section that's been pulled out of the periodic table is the lanthanide series, the other being the actinide series, which would be elements 89 to 103. Yeah, that's basically just core memorization. So yeah, overall, I hope you learned something. That's all I have for now. Again, I'm not going to go into specifics about these different topics in the periodic trends because there's enough content for their own videos and their own units. So this is just sort of a basic overlaying of some of the information and trends within the periodic table to show how well the periodic table is actually set up and how much it actually flows within itself. So yeah, that's all I got. Hope you guys learned something. Keep practicing. See ya.